Hello, everyone. I'm Sarah Seibert, Managing Editor of CIO Media and Research. I'm super excited to be joined with you all today in our esteemed panel. So in just a few minutes, you'll hear from Dr. David Aha, Director of the AI Center at the Naval Research Lab, Wole Moses, CAIO for the Federal Civilian part of Microsoft, Martin Stanley, AI and Cybersecurity Researcher at NIST, and Zach Whitman, Chief Data Scientist and CAIO at GSA. So the lightning rounds are one of my favorite sessions. Each speaker will have about 5 minutes to present on a topic of their choice that's driving progress in federal AI. And after they present, we'll turn it over to you all for questions. So start brainstorming. If we don't hear from you, they're gonna hear from me. So I think they'd prefer you. To kick things off, I'd like to welcome Zach Whitman to the podium to talk about how GSA is enabling federal AI adoption.
All right, I gotta keep an eye on the clock here. About 2-3 years ago, before I came to GSA, our CISO released a interim policy that was designed to allow employees to use public LLM tools for non-sensitive use cases. The idea was they were hearing a lot about, hey, I'd like to use ChatGPT to do X, Y, and Z, whatever. And so they came up with a structure to allow the employees to try it out. This unknowingly kind of embarked on our movement towards a broad and leading adoption for practical and pragmatic use of generative AI as part of our general workforce for GSA. It was an interesting experiment. We were one of the first movers in establishing that type of a policy. A lot of folks followed afterwards. And there was a lot of risk associated with that. A lot of work that went into making sure that that risk was mitigated so that we would avoid some of the fears that Taka pointed out. Like the prayers was completely accurate. Like, what are the people going to put in that thing? How is that going to affect our data exfiltration posture? And so from a CISO perspective, it was a really interesting move. Knowing that we were safe in our data egress policies, the next step was making sure that people understood how these tools worked. We knew that the way towards broad, safe adoption is through practical, hands-on experience. But there was a limit to that. It was limited to non-sensitive use cases. People could only use it for very narrow experimental purposes. And half the time we would hear feedback being like, this is great, I just can't use it for my work. I can see there's value here. I've got a ton of use cases in my head, but I just don't have a way to do it safely. And so there's this clarion call for give us some tooling so we can begin to use this and so we can see some real experimentation. It's not just could this work, it's this does work. And so we immediately took the next step to study the behaviors of this. We studied how folks were using these public tools, where it was contributing value, where the potential ROI would be found, and where importantly were there barriers for them to use it. From that study, we then issued a bunch of pilots. We established a whole host of small-scale, localized pilots where folks could use it internally for their own work, but there were restrictions. Those pilots weren't allowed to bring forward the work outputs and use them as part of a production output. We had a number of safeguards in place. And what we found was that while there were a whole host of different types of applications, like Taka was pointing out, we had the chat interfaces, we had the integrated AI systems, we had the cool, hypey, right-hand corner, who turned this on type features. We also had a number of folks that were calling out for, like, I would love to bake this into an automated process. So some of the more homegrown and agency-specific applications. What we understood, though, was that we need a wide application of tooling. Not one size will ever fit all, but also one modality will never fit all. We understood that it wasn't just a chat interface that was going to win the day. It will win the day today because that is what's available and what people understand, as oftentimes it turns into a first step. But that second step was what we were worried about. Where is the call for the APIs? Where are the calls for the integrations into their existing systems? And so that's where we wanted to really focus. And so with all of that information, with all those studies, we built out a platform that was a composite of three main components. The first one was a chatbot, the idea that folks could now freely interact with these basic tools that they've tried out and now understand how to use. The second was an API platform, one that not only exposed a whole series of these models that they may or may not be using in their chat, but also additional types of models, like embedding models, ones where they could vectorize their data and then begin to use it in a more programmatic way. And then the third application that we built was a console, a way to understand the behavior of each models. We understood that when we look at the telemetry of how folks use chatbots, they often don't engage with the models. They don't engage and change models because there's no real impetus for them to do so unless they are potentially experimenting with this feature. We know, though, as practitioners, that there are huge differences in the ways in which these models behave. And so what we set out to do was to measure the quality and evaluate the consistency and accuracy of the models for specific types of applications that were being executed with the chatbot and with our APIs. We wanted to constrain the expertise of the models and do so in a quantitative way, and one where we can reproduce and do it over and over and over again as new models come forward and as these models are being applied to different use cases. Our focus was making sure that we can constrain the functional space of GSA for each model and be able to prove reliably that these models are performant and meeting precision and quality thresholds. With all of this, we're understanding that there is an additional need, and that need is to expose this type of a feature set to other agencies, and that's what we're exploring right now. GSA has built this platform, and we are in the business of building shared platforms, and so we're exploring what that would look like for other agencies so they could immediately bootstrap into a platform that not only provides leading models for general work application, an API that could be used across a wide variety of their existing tooling, and a way to reliably measure the quality performance of these models and do so in a very safe and transparent way. That's my time. Thanks.
All right, thanks so much, Zach. Anyone have questions for Zach? All right, I have one for you. So how are you changing training within GSA and across government to boost adoption?
So the UK came out with an interesting study where they had kind of a three-phased approach to adoption. And the first one was practical hands-on application. We knew that folks wouldn't feel truly free to use the tools without a safe environment to use it in, and where we applied a lot of those safety controls. And so while we had training beforehand to get people up to speed with a lot of the commercial tooling out there, there was always this barrier of adoption where they're like, yeah, this is great and all, but like I'm afraid of this, or I'm not sure if I can use this appropriately. When we removed the guardrails and we're able to tailor the use to local use cases, we saw a lot more direct adoption. I'll also say there's a lot of network effects. So when we apply this tool to all employees, it's very different than allowing a couple folks in the agency to have like a license and then them learning on their own. When you have coworkers working together and all have access to the same tool, they learn from each other and they can build up their expertise together. And that was something we wanted to lead into.
Yeah. Thank you.
Thank you.
Yeah. Anyone else? All right. I'll go ahead and turn it over to Martin Stanley from NIST to talk about the intersections of AI and cyber. Thanks, Martin.
Hey everyone, and great, I think, previous sessions. Both of the previous speakers talked about the risks, the opportunities, and more specifically, how do you determine, are you seeing these risks and opportunities with AI? And that fundamentally comes down to being able to measure the performance of AI systems, which is a unique challenge in and of itself. At NIST, where I lead the AI risk management framework effort, we're focused on two things. One is obviously expanding the capacity for organizations to manage the unique risks introduced into their enterprise by introducing AI, as well as how to measure the performance of the systems. NIST is an institute of metrology, of measurement science, for those that are not familiar. So how many of you have heard of the AI risk management framework from NIST? All right, well, now you all can say that you've heard of it. I'm supposed to actually demonstrate some kind of measurement of that so that I can prove that we're relevant. This idea of demonstrating the return on investment of AI systems is in M2521, which Taka was talking about. There's a requirement for agencies that implement AI to show that they've actually done it in a way that's improved some aspect of the way that they deliver their services to their stakeholders. And so, really, as you're deploying AI, you should be thinking about, how am I to answer the question, did we make things better, did we make things worse? And more importantly, how do we know? So I mentioned at NIST we're coming up with new methods for measuring systems. I'm not going to talk about that too much today, other than to say if that's a topic that's of interest to you, and it probably should be. We have a number of research programs at NIST, in particular the ARIA program, Assessing Risks and Impacts of Artificial Intelligence, which gets into the unique aspects of and challenges with measuring the performance of AI systems, because we simply can't use benchmarks and black box testing alone. We have to understand what's done with the outputs from these systems by all of us, and what are those impacts, and what are the benefits as a result of using that information. And I think we've all seen these challenges, and we've certainly read about them. When we talk about AI risks, I'm going to get a little bit more specific. Oftentimes we focus, I think, on things like mission risk. We don't get into the level of detail that focuses on the uniqueness of these systems and the way in which these systems behave and operate, and how that can impact your risk considerations. That there was a great description by Taka on this whole vectorization of data, and prediction and all of that in generative AI systems. So one of the things that he didn't talk about was some characteristics that we measure in AI systems, which are, like, for example, overfitting, underfitting, model drift. You may have heard of all these terms. Well, to put it into real world considerations, if you're operating Netflix, overfitting is probably okay, because maybe I get a few things that I don't like in my recommendations, but at the end of the day, I'm getting more out of their catalog, and I'm less likely to switch over to Amazon or something else by staying within their environment. Overfitting, when you're trying to determine is the object that I'm recognizing a stop sign or not, is probably problematic, as is underfitting. So the accuracy and interpretability of those outputs is really, really important in that particular context of use. So I promised to talk about cybersecurity in the 56 seconds that I have left. So artificial intelligence systems introduce some unique cybersecurity risks. NIST, obviously, you're familiar with the 800 series, cybersecurity framework and all of that, has tremendous expertise. Over the next 6 months to a year, we're going to be expanding on a workshop that we had back in April regarding the intersection of AI and cybersecurity, and in particular, looking to develop an 853 control overlay. So this is the control catalog from the 800 series, which will focus on, what are these unique risks that we have in AI systems that cybersecurity can potentially assist with. Models being, fooled, or the training data being stolen, or, the models themselves being stolen. Can't do all of it, but cybersecurity can contribute in a big way. And then also a longer-term project for us is a cybersecurity framework profile for AI. And that's timer's at 0. Any questions?
That cybersecurity framework for AI, what's the timeline on that, or is that not disclosed?
So we just had a workshop we released the readout from the workshop. There's going to be a draft that's developed as a result of that and the RFI. It'll probably follow the typical NIST public process. We don't really give time frames around that, but I think you should expect at least 2 opportunities more to contribute at workshops and through public comment. So maybe 9 months to a year, something like that. I think the 853 control overlay is going to come out a lot sooner than that.
All right. Oh. Going back to where I started. Sorry about that.
Hi, how many of your government counterparts, these emergent CAIOs, are actively engaging with you right now to understand the NIST framework you're building and to contribute to it?
Sure. So we actually have been an active contributor to the Chief AI Officers Risk Management Council since a year and a half ago. So we work with all the Chief AI Officers pretty regularly. Obviously, M2521 is more of like a profile for the AI Risk Management Framework, where it talks about particular aspects that agencies need to be focused on when it comes to deploying AI. You can certainly use the AI Risk Management Framework, and it even indicates within the memo that that's something that agencies can use. So we work with the broad interagency. I was at CISA for 11 years before this, so I worked with the broad interagency on FISMA. So there's pretty long history of working, obviously with OMB and with CISA and with NIST. But I think I'm trying to remember the second part of your question was.
Are they contributing?
Oh yeah. So we have a bunch of like individual engagements, and we are actually seeking those out. So if folks have a particular use case, I like to focus on like inherently governmental use cases, things like how do you process RFI comments, things like that we do pretty regularly that isn't something that is probably likely to become commercially available. We have like one-on-one engagements with federal agencies if there's something in particular that they're trying to execute.
Anyone else? All right. Thanks so much, Martin.
Thank you.
Next, I'd like to welcome Wole Moses from Microsoft to the podium. He will talk more about best practices for AI governance. Thank you.
Thank you. So my topic's a little bit different. What I'm going to talk about is best practices for deploying AI use cases in government. And so, as mentioned, I'm the Chief AI Officer for Microsoft Federal Civilian. It's obviously an exciting time to be involved in AI, especially over the past more than 2.5 years with the advent of generative AI. And so from a Microsoft perspective, we've had an opportunity to really get a great bird's eye view of what's happening in the federal government through our work with federal agencies and our partnership with agencies in helping them explore and deploy AI capabilities. And so I have a paper that I'm writing. What I'll give you is a condensed Cliff Notes version of it. Does anyone remember Cliff Notes? Do they still exist? I'll give you a condensed version of that paper in the time that I have remaining. So there's really around 4 categories of best practices that we've seen agencies that have been successful with their AI projects take on. So first of all, alignment to agency strategy and priorities. Instituting an organizational culture to support AI. The next thing is governance, ensuring that governance is in place. And then finally, really locking in on a technology strategy. All of those things have actually been talked about earlier today by previous speakers, Zach, Taka, as well as Lakshmi. And so I'll give a few sort of examples of each one of those. And so starting with alignment with agency strategy, where we've seen successful projects, those projects have really been laser focused on critical or in some cases visible agency components of the agency mission. And so even where we've seen IT-initiated projects, those projects have really been focused on things like how we can save cost, improving citizen experience, really aligned to the agency mission. So in other words, not AI for the sake of AI. The other thing that we've seen, the other thing I talk about here is that we've seen agencies who've had success in their AI projects really think ahead to in the beginning, in the thought process, in the ideation. They've already started to think about how are we going to measure the impact, and so they don't wait until the end. They from the very beginning, while they're conceiving the AI project and thinking it through, they already start to think about quantifiable metrics for how they're going to measure the impact later. And so alignment to the agency strategy, super important, both in terms of getting support within the organization as well as getting funding. The second thing that I talked about is organizational culture. That is also super important. The first thing I'd say is that really thinking about the sort of landscape we operate in and a lot of the concerns people have about generative AI. And so we've seen agencies that have been successful around organizational culture really anticipate proactively some of the concerns that the workforce may have about generative AI. So really being empathetic around some of those concerns and really addressing those proactively. The second aspect of organizational culture where we've seen successful agencies do is really implementing training. So a couple of people have already talked about that. Really implementing instituting continuous learning. If you think about the pace of change of AI, I know personally I have to spend my weekends. It's something that I'm passionate about, so it doesn't feel like work, but I have to spend extra time keeping up. And so really creating an environment where that's possible. I'll call out one agency. This isn't the only one that's doing this, but one of the things we've seen is I'll call out NIH. Nick Weber specifically is one of the leaders of NIH. They started an AI community of practice where I think at the point where I talked to him about a year ago, it was like 350 people across multidisciplinary across roles, researchers, attorneys, folks within technology. But it's really a meeting of people who self-selected, who came together, who wanted to learn about AI. They called it a safe space for people of all levels to learn about AI capabilities, to talk about risks, to talk about concerns, and a lot of their use cases that came out of NIH emerged from there. And then the last thing I'll talk about in terms of culture is really having a culture starting from leadership that recognizes AI, recognizes and supports AI work. And so one of the things that I do in my role is I work here, I'm a subject matter expert for the Partnership for Public Service AI leadership program. And so one of the, there's a particular person from an agency, and I'm not gonna call out this specific agency, but he let me know that one of the things that drove their success was that the secretary of that agency actually made it was very conscientious in calling out, giving shout outs and recognition to folks within the agency who developed different AI projects. And so that sort of provided encouragement for others, and then also in some cases, competitive juices between different parts of the agency started to flow in a good way, and so that really stimulated the development of AI use cases. And so that's the last thing I'll talk about in terms of the organizational culture, leadership support, and those shout outs really were helpful. The next thing I talked about was technology strategy. So really thinking about, in a thoughtful way, the technology choices. I have a talk a little bit later where I'll talk about this sort of paradigm that we have now that I call build, buy, or customize, or build, buy, and extend. So are you going to build your own AI solutions? Or are you going to buy a SaaS solution? Are you going to customize and build on top of a SaaS solution? Those are some of the things that have to be thought about. Taka talked about the data strategy as well. You can fit that under thinking through the technology strategy. So really being thoughtful and ensuring that your technology stack is sufficient to enable successful AI projects. The last thing is governance, and so we heard about that one in the last presentation. Really thinking about governance, but not from the standpoint of using governance to stifle AI projects and stifle innovation, but really coming from a mindset of using governance to actually build trust in the AI work that you'll do, that you're planning. And then that trust actually stimulates adoption. And so those are the four things that, if I call out some of the four success factors that we've seen with agencies who've been successful with their AI projects, those are the four that I would call out. Thank you.
Thanks so much, Ole. Any questions? All right, I have one for you. So you mentioned the progress you saw at NIH, and it's funny, we actually have Nick speaking at a virtual event coming up. But what contributed to that? Could you dive a bit deeper? I think it's easy for people to say, like, oh, yeah, best practices training's important, but what made it successful at NIH? Or if we want to go with a different federal use case, what really drives success when focusing on these?
Yeah, so NIH in specific, what I was really calling out was the NIH community of practice. They have an AI community of practice that they stood up. It was organic. From what I understand, it wasn't something that the organization asked anyone to do. It was just, like we talked about earlier, that curiosity to learn about technology and the curiosity to learn. And so what made that successful is the fact that they were cross-disciplinary. So they didn't have a bunch of folks just from technology. They didn't have a bunch of folks just from legal. They had folks from across the board. So they had researchers, they had folks who understood technology, they had data scientists, they had lawyers as well. You have to have lawyers. But they had folks from all disciplines within the organization. And so what happens when you have those different points of views is that you eliminate a lot of the blind spots. And so me specifically, I'm a technologist. I love technology, but there may be other things I don't think about. They had sociologists from NIH who were participants as well. And so really having that multidisciplinary, varied group of folks with different experiences help bring in lots of different viewpoints that really rounded out the way they thought about their AI use cases, the way they thought about risk, the way they thought about training. And so that's one thing I would call out.
Right, that makes a lot of sense. Thank you. Anyone else have questions? All right, thanks so much, Wole.
Thank you.
All right. And our final speaker, we have Dr. David Aha from Naval Research Lab to talk about AI in action. Thank you.
Thanks very much for having me. I'd like to just talk a little bit about our research center and the broad AI project portfolio that we have. But I need some notes to do this, so excuse me. So the Naval Research Laboratory is the Navy's full-spectrum corporate research lab. It conducts multidisciplinary research and advanced tech development towards maritime applications. The parent organization is the Office of Naval Research. The emphases there include that we work at all classification levels, from unclass to well above top secret SCI. We have a very deep technical base. We're part of the Naval Research Enterprise. We develop and maintain deep connections with both warfighters and the scientific community. Our primary locations are here in DC, also in Stennis, Mississippi, and Monterey, California. We have 17 divisions. They are structured into 4 research directorates, as they're called: systems, material science, and component technology, ocean and atmosphere S&T, and then the Naval Center for Space Technology. We're part of the Navy Working Capital Fund, meaning that we have to raise every penny and all of our costs ourselves. So we're not given any funding directly from Congress. We're not congressionally mandated. Our center's name is called the Navy Center for Applied Research in AI, or NCARI. We're part of the IT division within the Systems Directorate at NRL. What we do is we conduct basic and applied research in topics pertaining to AI, cognitive science, robotics, and related areas, all towards the demonstration and potential transition to critical Navy and Marine Corps applications. So I'd like to tell you a little bit about the structure of the organization itself. We have 4 sections. The first is called the Integrated Cognitive Systems section. They create computational cognitive architectures that integrate perception, cognition, and action to enable deliberative and reactive processing. And they're interested in things like theories of attention and moral cognition, amongst other topic areas. The second section is called Adaptive Systems, and they work on systems that can adapt their performance to unforeseen or unpredictable environmental changes over time. So focal research topics there include, yes, machine learning and a subset, Gen AI, but also automated planning and acting, intelligent agents, human-machine teaming, human-robot interaction, etc. The third section is the section that is dominated by cognitive scientists. They call it the human and machine intelligence section. So they work on things such as creating embodied intelligent agents that interact with people. They work on theoretical and applied systems for perception, reasoning, interaction to improve human and AI systems based on cognitively plausible models of cognition and behavior. The final group is a robotics group. Their name's the Distributed Autonomous Systems section. As you can imagine, their focus is on swarm intelligence. So they do things such as develop software for controlling and countering swarms of vehicles for the air, land, surface, undersea domains. They're interested in things like bio-inspired designs of their systems, and they go after things such as sensing, navigation, and decision-making tasks in their work. Example applications areas across the board with respect to the center are unmanned autonomous systems, command and control, cognitive robotics, computer vision, human-robot interaction, human-computer interaction, as well as intelligent decision aids, mission planning, all sorts of things of that nature. And what distinguishes us from the rest of NRL is that all the divisions at NRL are working on applications of AI to the kinds of things that they're interested in, and we're working with some of them. We're different in that we're really pushing the boundary and the state of the art of AI today. So examples of some of the things that we do with others across the lab is that we're working with biologists to speed up the analyses of water samples. This is in the context of the study of proteomics. We work with chemists doing things such as using smart sensors to do person identification. And we work with space scientists. For example, they're interested in intelligent agents that have the capability to support satellite scheduling and other kinds of tasks like that. So I'll drill down to two quick examples of efforts within our center. The first is called, of all things, GAME. And GAME is a project that's leveraging large language models for air combat mission planning. So it works as follows. Given an operations order in text, it performs automatic situation summarization and placement of assets onto a map. It automatically generates the red team's courses of actions using a selected persona, such as most aggressive, etc. It simulates execution of these courses of actions step by step, and it can support the interrogation of results. So there's a great deal of interest that we have here with respect to that project in the context of wargaming. The second topic I'd like to mention is that of robotic shipboard maintenance. So one of our sections is particularly focused on using quadruped robots, in particular the well-known Boston Dynamics Spot robot, which is a terrific research platform if you're not already familiar with it. But we've significantly extended it so that it can do things such as accept as input natural language instructions that include spatial directions, navigate over knee knockers, which you'll find everywhere throughout the Navy ships, select tools autonomously from a pegboard, perform handoffs of these tools to humans, and that's actually a very difficult task. Apply some of these tools. And their current focus is on things such as detecting and responding to unsafe ship conditions, things of that nature. So, final note is that the two topics that, of course, you're familiar with today in AI and in our sphere, generally speaking, the two most popular ones are Gen AI and autonomous systems, respectively. And I just do want to point out that we are working in those areas. For example, we're leading the Navy Gen AI Community of Interest, which is meeting bi-weekly and has a very large turnout. We're hosting weekly machine learning research presentations. With respect to autonomous systems, we do work on counter unmanned air systems, control of solar high-altitude balloon swarms, things of that nature. And we're very much involved with all the communities in that regard. Thank you.
Thank you, Dr. Aha. Any questions?
Dr. Falk, do you want to play a game of chess?
Yeah. I get that a lot. So, and I recognize also I'm the very different perspective here as a researcher. But if you have any questions on the topic, I've got about 42 years of looking at it. So, yes.
For the AI, I know you partly together look at agentic AI as well. Have you looked at like the security implications of using agents? Because how they I look at them as implants instead. Because I mean it's the same as an implant. Like it has access to everything that an implant would. So like how would you go about securing that? Like if someone gets access to your agent, they have access to everything because it needs to be before the encryption.
Yes. So we have, I'm involved in a project that's particularly titled Risks with respect to Gen AI and things of that nature. But we have a separate organization, a sibling organization within our division that's specifically focusing on cybersecurity. So they tend to get to do all the fun stuff in that regard. They have already supplied the Navy with a machine learning focused toolbox, if I can call it that, for doing things such as detection of malware and stuff in previous generations of their work. And right now, yes, they are looking at issues with respect to agentic AI and things of that nature. And of course, we're looking at, but our focus is more on what can be done to expand the set of capabilities of agentic AI systems to support Navy and Marine Corps applications right now, as opposed to, okay, let's now worry about safety issues. And while we do consider them in our research, it's not our primary focus.
Thank you. Any other questions?
Thank you so much. What are some of the challenges that you experience in scaling the AI?
Well, first and foremost, I'm talking with my ARL colleagues, Army Research colleagues, and others all the time. And they are, and in general, the DoD research laboratories are very concerned about the fact that we can't do pre-training because we don't have enough cycles. So they're very interested in being able to spend an awful lot of money so that we can support that. In contrast, when I speak with my section heads, their strategies are saying, look, we're never going to get there, and we're not that interested. And honestly, a lot of the research is on using what's there and seeing how we can focus on other aspects of research that is more appropriate for us to be looking at rather than trying to be duplicative with some other work that's going on in industry and so on and so forth. I'm not sure if I answered your question. Okay.
All right, thank you so much, Dr. Aha. And let's get another round of applause for our speakers. It was really interesting to learn more about what you all are working on and the different applications, so thank you again.